Sorry. As I said in class today, I do this video so that if you didn't get an chance to actually see it, you can go through it. So, really, today's question, which is a truncated code, is about ratio. So that's the first thing I'm going to talk about. So some common ratios that we usually see are, it's like a fraction is a common example of a ratio. So it's 1 part of 2, or a ratio that's in it. We're going to use this information, so like 3 parts of 5, for instance. We're going to use this as our ratio today to help us solve this question here. But before I even start, the first thing that I'm actually going to do is just have a bit of a think about how I would even find the volume of just this particular part of a shape. Well, this gives it away a little bit because it is, of course, a truncated cone. So what I'm going to do is I'm just going to draw on there a little cone. Now, I don't know how high it is. So I'm just going to call that X. And I know that it's got a radius of 2. And then if I look at this, if I could work out this cone and then work out the whole cone and take that bit away, then, well, this will be left, won't it? So I need to get some measurements because I don't know what they are. So what I'm actually going to do is I'm going to look at this height. I'm going to say, well, if it's X from here to here, so this is X, and then it's 6 from there to there, then I'm actually going to say the whole thing is X plus 6. So that's one way in which I'm going to show the ratio of this particular cone. So that leaves me with, of course, the problem. I've got to be able to find X. So how do I do this? And, well, first off, what I'm going to do is I'm going to take this triangle here out. I'm going to draw it here. Now, I'm actually going to draw it in a slightly different way. Oh, no, okay, I'll draw it this way. Usually I draw it sitting down, but it probably makes more sense if I draw it this way. And I've got some measurements that I can put on it. I know that this is 5, because that's the radius. I know that the radius here on this shape was 2 from our original question. I know that from here to here is X. I know this bit is 6. And I know the whole length there is X plus 6. Now, funnily, the ratio of this side, X to 2, because this is the same angle, is the same as the ratio of this side, which is 5 to X plus 6. So how would I write that? Well, we talked about fractions before being a way in which we can actually write ratios. So I'm going to use that knowledge to help me write it. So I said that the ratio of X to 2 is the same as the ratio of, well, X plus 6 to 5. So that's one way we can look at it, because we can look at that same triangle. And if you're interested, come see me and I can show you another way using simultaneous equations that we looked at recently. So what I'm actually going to do today is now I've got to solve and find for X. Well, if we remember from our linear algebra that we can actually use the crossover method. So here I'm going to cross this over and go 5 times X, which is going to give me 5X. And here I'm going to go 2 times X plus 6, which I need to put in brackets because I've got to times 2 by both. So 5X is going to be equal to 2X plus 12. And then if we look at this particular thing, can I solve this? Well, I can actually take 2X's from this side and take 2X's from the other. So as long as I'm doing the same on both sides, it doesn't matter. And that's going to give me 3x is equal to 12. And of course, I could divide that 3x by 3 and the 12 by 3. So I now know that x's value is 4. Well, once again, it's always good to stop and think of what I've actually found. So what I found is this height. So in the actual original diagram, it's this one in here. I'm going to write it in. So 4. Okay, and I've also found, funnily enough, this. Because if I know that x is 4, this is going to be 4 plus 6, which is going to give me a height of 10. So I now know that the height from here to here is, of course, 10. So now that I've worked those things out, I can start doing my volume. So what I'm actually going to do is I'm going to call this shape up the top shape 1, and I'm going to call the whole cone shape 2. And I usually like to do it that I redraw my shapes. So just so that I've got everything in the right place. So here we go. I know that that's 4. And I know that this here is 2. So if I remember my formula for a cone, well, the volume for a cone is a third pi r squared h. Okay, so if I grab a calculator, I could, of course, well, first off, I'll fill the values in. So I've got a third times 3.14 times 2 squared times, of course, h, which is 4. So I'll whack that into a calculator. So it's a, if I turn on first, that might make it a little bit easier for me. So a third times 3.14 times 2 squared times 4 gives me the answer of 16.74. Now I have rounded that. So probably better if I rounded it. Well, I'm just going to put a 6 on. I'll do 3 significant figures. So that is the volume of which part? Well, it's this cone that, funnily enough, doesn't actually exist. And then I need the volume of the whole cone, so I can take this one away from it. So I think I'll do that over here. So just a slightly bigger cone. Oh, didn't draw that one great. And of course, we know that our radius is 5. And here we worked out how tall this was. Now, just be careful because some kids will come back to this and they'll use this 6. No, once we've done this part, we don't need this 6 anymore. Remember, you found it to being 10, so just be careful about that. And once again, volume of a cone is a third pi r squared h. So putting in what we know, it's a third times 3.14 times our radius, which is 5 squared, times, of course, by our height, which is 10. So that gives us a volume of 261.666. Put my figures in, and then, well, my total volume, or volume T, is going to be 261.666. And remember, this isn't here, we want to take it away. So I'm going to take away 16.746. And if we do that in our calculator, end up with 244.92. So that's how you deal with a truncated cone. The same thing can be said for a frustum. You know what that is? It is a pyramid with the top cut off. However, there is one thing that I just want to point out. If you do have a look at the worksheet that you've got today, you'll notice the frustum has usually something like a 3, I think the question has, and a 6. Just remember that this side, which you'll have to work out, because remember you need the base area, is actually 12. It's double this. And a lot of kids made that mistake when we're doing this in class. And of course, once again, this 3 across here, what's 3 to there, 3 to there. So this is 6 as well. And though it doesn't actually look like it, this is a square-based pyramid. So they're both 12. And of course, this is 6. So just be careful when you look at that. And if you're working with me tomorrow, remember we'll look at what happens when we don't have the right sides. But this really is the trick today. the ratio trick. And if you'd like to come and see me later, feel free. I'll be free Wednesday, Thursday, Friday as well. Okay, see you guys.